As I was saying in the today's presentation, we'll briefly see about modeling approaches and how or why one can use GTS and NX so that their analysis model methods are a lot more simplified using our wizards or tunnel lining plots. So we'll see all of them in today's presentation. Followed by that, I'll also demonstrate you model where we will do a tunnel excavation adjacent to a high-rise building and assess how the excavation impacted the building displacement or behavior. So I hope my screen is visible to all. Yeah, as I was saying, for content for the today's presentation would be sorry, we will begin with a brief background and then we will see the modeling approaches and modeling approach, and then I'll demonstrate you the numerical model, how you can import the structure that is already created in Zen or Civil into GTS NX, and then how you can develop the ground models and carry out the impact analysis. To begin with a brief theory, there are various methods of construction, tunnel constructions. So only few have been highlighted here. I'm sure there are many other methods that are worldwide followed. So some of them which I have highlighted here are the cut and cover tunneling method, which is mostly followed in a, when the tunneling is carried out at a very shallow depth. And then there is a one old most method that is followed across the world is a drill and blast tunneling method, which is also a very ancient technique. And then we have a tunnel boring machine, which is largely used in urban populated areas for the metro constructions or for the underground subway systems. And we have a sequential excavation method, which is also called as NATM method, new Austrian tunnel method, where the tunnel is excavated in each steps and the ground is allowed to have the stress relaxation, and then at a particular point the linings are provided to resist the uh, ground displacement. So so this is NATM method, and we have the last method that is highlighted here is jacked box method. So all in GTS NX, you can model your tunnels using a TBM approach or even the NATM approach. So we will see which method is to be followed for construction depends on a lot of parameters. Basically, what is the time that is required in the site preparation, what is the excavation rate that you would like to have. Suppose you have a tunnel boring machine, then you can have a very high excavation rates of 15 to 50 meters a day. Whenever you are going with the drill and blast method, you have very limited amount of excavation that is possible. And then what is the tunnel shape that you would want to have, because TBM is would give you a lot more uniform cross section of the tunnel, but drill and blast would typically give you a horseshoe shape, which requires the treatment on the later stages. And then where you are currently working, that is whether it's a populated area or unpopulated area, you are a lot more restricted in terms of using drill and blast method whenever you are working on a populated area. So in such cases you can use TBM approach or NATM approach. And what kind of ground vibrations are allowed during the construction by measuring the peak particle velocity. So you can adopt whether you both drill and blast or the TBM approach. And it also depends on what kind of labor work or labor force you have, because each method requires its own skill sets. For example, drill and blast, you should have the people working should have a knowledge on blast and other things. And whereas TBM approach, whenever you are adopting, you have a dedicated team which can operate and handle the tunnel boring machine. So these are the various parameters which are generally considered for adopting the type of uh, tunnel excavation. And coming to the today's topic, why one should have an impact study, because tunnel is a different thing and structural analysis is a different thing, and why it is required to have an impact study basically. So if you look at historically, both in India, or I'm sure in your own respective countries, you might have heard news of there is a sudden collapse of a building, and you will later come to know there is an underground excavation that was undergoing because of the subway station or the tunnels for the metros. So what basically happens is, the structure, suppose you have a structure here and this is the ground, and you have the piled up foundations, for so to say, and you are carrying out an excavation or a tunnel near to it. And if you do not consider the proper soil properties, and if you don't carry out the impact of the excavation onto the existing structure, and the seepage analysis, sometimes what might happen is the soil that is coming in between might get overstressed, and this might result in collapse of this building. So there are already examples. For example, if you see here, this is an example, Cologne, Germany, where an archival building got collapsed because there was a failure of the diaphragm wall. So the eyewitnesses or the few studies say that this happened because of the excessive seepage of water and soil into the excavated area. And in a lot of the cases, the TBM gets stuck in the excavation areas. For example, this happened in Kolkata, and I'm sure there are many other examples as well. So all these aspects, what they tell is it is very important to have important to have an assessment of the excavation onto the nearby structure or the adjacent structures. So now you all might be wondering why I should use GTS NX. Okay, so what is the benefit if I'm using GTS NX? Because the tunnels are, tunnel and underground excavations are very complicated models, or the problems to be modeled in a finite element software. So, but GTS NX has a wizards which were very helpful for the engineers in order to quickly model and analyze the tunnel objects. So, for example, if you see here, we have a tunnel modeling wizard, which I'll also demonstrate you through the GTS NX application as well. If you look here, we have a wizard where one can enter the details of a tunnel and what kind of support system you would like to have, that is shotcrete, rock bolts, and you can also define the excavation sequences, and then your entire model is created. Suppose here I'm inputting the dimensions of the tunnel, whether I would like to have a bench cut 1, bench cut 2, ring cut, and I'll also give the dimensions, for example, radius and the angle of intersection. And then I'll define the shotcrete or the rock support that I would like to have, what kind of lining I would like to have, and what are the properties of the lining. And similarly, the number of rock bolts I have, rock bolts, its length, and the distance, tangential distance between the rock bolt. So all these things are defined in the second step. And in the third step, you define excavation sequences. For example, I would like to have 30 excavations at a 2 meter at a time, and I'd also like to have a support in between the excavations. So all these excavation sequences are given as a third input. And then the final is the, suppose you have a tunnel here, and this is the overburden, total overburden, and you would like to include the exact topography of the soil, then you can include the terrain and the strata as well. And you can define the stratas by considering its contour data or a DM data, elevation data. And then the software would give you the entire, would generate the entire tunnel model itself. So this is quite helpful for any initial assessment. Suppose you want to carry out a quick analysis, so you can use the tunnel modeling wizard in your analysis. And this is the video of uh, the tunnel wizard. So I'll show you let us see. Yeah, here we are choosing the tunnel model, and then we are adding the details of the shotcrete, the dimensions. I'm defining the excavations. Then I'll define the mesh property that I would like to have. You can see the entire 3D model is getting prepared. So this is quite helpful for the engineers who are working on a very initial assessments. And coming to the today's problem, impact assessment, how one can approach in solving the impact assessment of the structure. So there are basically two assumptions where one you can model the entire building as shown to the right side, and then you can model your tunneling. So basically, once you start executing the tunneling excavation, you can study the impact on the your model or the structure as a structure. Or else you can also do import all the structural loads that are coming on to the foundation. For example, a pile draft foundation, you can import all the structural loads, and then without modeling the structure, you just need to model the foundation and the loads, the superstructure loads that are acting on the foundation, and then you can model the tunneling as well. So these are the two approaches that one can follow. But in most of the cases, it would be a lot more beneficial if you have a entire structure along with its loads and the support system. So suppose you have a problem of this kind, and you want to control the displacement that would be resulted because of the excavation. Then you would be going ahead with the ground improvements techniques that are near to our tunnels. For example, here we have two methods which have been highlighted. One is jet grouting, another one is ground freezing. Even though the ground freezing is a lot more expensive, so in most of the cases jet grouting is adopted. How jet grouting would help you in controlling the displacement or improving the soil parameters. And in the today's in the webinar, we will consider the problem that is shown here. It is a G plus 25 building with pile draft foundation, and there is 4 layers of soils here, and we have a tunnel that is being excavated, and we will see the uh, how the building behaves due to the excavation that is carried out in the tunnel. And the entire model dimensions are around 100 meter and 72 meter, and the depth of the soil is around 45 meter. Okay. Sorry. And yeah, this is the geometry. We have around 73 piles, a pile raft of thickness 1 meter, and the length of the jet grout is around 42 meter. And we will try to simulate this problem. And we will have the initial shield of 50 and then later, using the change property parameter, we will define a final liner of 350 Okay, so and how yeah yes. Yeah. See, initially, the entire ground profile will be of soil, and then, you excavate certain area. Just let me change the color of, yeah. Then you would change, you would excavate for the raft and the pile. So, and then you backfill with the gravel material. So this cushioning will be given based on the gravel material. So this we will change the property using the change property function in the GTS NX. Similarly, initially we will be giving the shield, and then later on we will replace it with the final liner. So again, this is done using change property function. And similarly, the ground which is initially is of ground soil layer will be changed to grout once you are using a grouting. Okay, so we will see these things. And this will be the construction stages. Initially you have the ground profile, and then in the stage one you have a cushioning and the pile raft, and then you have the entire dead load from the superstructure. and then you have the tower, that is the building that is imported, and then you would begin with the excavation sequences, that is you start tunneling, and then you replace it with a shield, and then you change the shield to the final liner after the two stages of the excavation, and then you would also activate the jet grouts as well, so that you have controlled or the improved ground parameters. I'll just play a small video, how the construction sequences will be simulated here. You can see first we have the uh, building with the pile raft, then we started the excavation for the tunnels. Okay, and this is for the presentation, and now I'll just show you how use how one can use basically the tunnel modeling wizard. Suppose as I was highlighting, suppose I'll choose, you can see here the option tunnel modeling wizard. Here, one can enter the different dimensions and the angles, and then the shortcut, what kind of properties you would like to have. Suppose here in this model, let us say I'll import. I have a shortcut properties, then the rock bolt. Suppose let us see a beam. Uh, Let me not have the rock bolt for this, and then I'll define the excavation 130 at the rate 2, and then I'll define the mesh sets, and I'll just define the I'll just say the okay, we'll define the general properties as well, uh, and you will have a entire model created. And also I would like to also show you the tunnel lining plot. Suppose you have already created, analyzed your tunnel, and you will have your results of the lining. Suppose you will get the bending moment, axial force, on the shear force, and you want to know the whether your the capacity of the lining is sufficient or not for the proposed factor of safety. That analysis can also be automatically done in GTS NX. You can just enter your moment and the shear force and the axial forces here, and you can enter the material properties of the steel and the concrete, and can give the factor of safeties, and the software will automatically calculate the capacity curves, and it would say whether your the giver the lining or the rock bolts that is given is sufficient or not. So these are very helpful in terms of analysis of tunnel linings and support system. So all these are very helpful for the engineers in their day-to-day activities. Now, for the today's presentation, for the today's seminar, let us create the model that, yeah, this is the final model that we will be working on. So now let us open GTS NX. Yeah, just give the name tunnel assessment. Since we are doing a 3D, so we are selecting a 3D, and just let me hide the static load, which is predefined. In GTS NX, you can import, your drawings based on various formats, whether it's a CAD format, DXF, or DWG. And suppose you are using any other MIDAS family FEM platform for structural analysis, for example, Zen or Civil, then you can export the structure along with its results, and you can import the entire model in GTS NX. See here, this model is already analyzed, in MIDAS Zen, and now we have imported the entire building with its load on the raft and the foundation, that is piles as well. So I don't want the reactions here, so let me delete them. Yes. Yes, let me delete the reactions. Now what we will do is we will import the entire results or the superstructure results as well. Import the nodal results. You can see here the axial loads, vertical loads, and the moments are all imported from the analysis or the structural analysis. Okay, so that you can see here we have included the dead loads and the live loads as well. Now the step is to create a tunnel. Okay, so how we can create that, so that we will see. Now what I'll do is I'll just change, uh, the dimension of the grid. Let's say 10 meter will give you some 100 grids on both the direction. And if you see here, yeah, yeah, here, if you remember our model, the tunnel was around 10 meter from this end and 16 meter below this. So we will create an approximate model, 10 meter. Here, a radius, we would have a radius, and this we will give it as okay. See here, we have created an geometry for the tunnel. Okay, and we also need a geometry to create the grouting as well. So that we will do. Before that, let me again change. I'll change it to 1 meter, then just check okay. Here if you measure the distance, we created a tunnel. uh, just 1 second. We created a tunnel of diameter 8 meter, and then I need to create a 1 meter thick grout. So what I'll do is I'll just create an arc. I'll just say okay, and now let me close this. Okay, and we will intersect all of them so that we will create the faces for the geometries to excavate the tunnel. Okay, so just let me delete, and let me create the face. So this would be for the tunnel, and this would be for the grouting. Okay, let me select the boundaries for the grouting as well. See, this is the tunnel. What we will do is, now let me create a soil domain first, so that your entire model and the tunnels are all included. So we will change the work plane to XY. We will select the top view, and then what we will do is we will again change the grid size to 10 meter. Let's say, yeah, 10 meter would fine. And I would draw a rectangle. Let us say first location would be, I have the coordinates -30 comma -30, apply. Then the other corner would be 60 comma 30. Okay, so this would be my soil domain. And since we are doing the raft as well, we will create a cushion around the raft. For that, we will define a small boundary surrounding the raft element. So let me again choose 2 meter, and here I'll draw a rectangle around the raft basically. So this would be the cushioning area that would be given. And if you see, we have defined the geometries. So, okay, before we proceed, what you can see here, if you check the mesh sets, entire your building along with the raft and the piles are of a one mesh set, but I don't want. I want a different building mesh set for different mesh set for building raft and the pile. So what I'll do is I'll simply create a new mesh set, and I'll rename it as piles. I'll create another mesh set, and I'll rename it as sorry, I'll rename it as raft. Then I'll create another mesh set for building building and this we will rename it as raft. Yeah, what I'll do is I'll include the respective elements in the each mesh set. Suppose let's say I'll hide all the geometry now for the moment, and I'll hide even the grids as well. I want to include the piles. What I'll do is I'll select the side view, and I'll right click on piles, and I'll include all the pile elements. I'll select the intersection option so that all my 73 piles all are now selected. I'll just add so that you have a different method for the pile. Okay. Similarly, we will add the raft as well. So what I'll do is I'll right click on the raft, and I'll just include all the raft elements. You can see here all the raft elements are now selected. They are assigned a raft, and now the remaining is building. So what I'll do is I'll hide piles and the raft, and only thing that is remaining is the building components, that is shear wall, diaphragm wall, or the beams and columns. So what I'll do is I'll just select everything and add it in building. So we have building, then we have raft method, then we have piles. Okay. Now let me develop the uh, geometry for the tunnel. So see, if you see that the tunnel geometry is right now located here. Now we need to translate that to this end so that your tunnel starts from this end to the last end. Okay. So for that, what I'll do is I'll just activate my axis. I'll use option called translate. All the drawings and options, as you can see, translate, extrude, all are CAD based software. So even though whenever you use it for the first time, you won't be facing any much of the difficulties. Okay. So I'll just move it by 30 meter in the negative direction, and if you just see here, I'll just click OK. So this we have, you can see here, if I go to the top layer, it is starting at the soil domain itself. Okay. So now what I'll do is I'll just extrude this to the last end. So I'll use an option called extrude. I'll just select the surface, then the dimension, then I'll just enter the length, and I'll just change the geometry set to tunnel geometry. I'll explain you how it would help you in the subsequent steps. Uh, I'll just select tunnel, and then I would click OK. See here, we have created a tunnel solid now. Okay. What we will do is now we also have to create the solid volume for the grouting. See, if you see here, grout starts somewhere here, but in actual, grouting would start, much earlier than uh, the zone where your building starts. Okay. What I'll do is I'll just before I do that, then what we'll do is we will divide this solid. Okay, so that I'll explain you, and so that it will help us in moving this grout geometry as well. What we will do is we will again go to the front view, because the tunneling is carried out in excavation stages. Suppose 2 meter, for example, let's say 2 meter. So we need to divide the solid in 2 meter stages so that uh, excavation excavation is can be carried out in sequence. So for that, I'll just define a surface. We can call it as a cutting plane. You can say this as tunnel only, no issues. If you see, we have a face here created. What I'll do is I'll translate that to here, then I will divide it. I'll replicate it 2 meters or 29 times, so that we will have a solids that are divided for every 2 meter. Okay, I'll use translate, then I'll just select this, then the direction, and I'll just copy it distance. I'll just first I'll move it a distance of -30. And if you see, if you just check the preview, you can see here. Okay, then I'll just click OK. What I'll do is then I'll again use the translate command to copy it. I'll select the direction, then I'll copy it 29 times. Distance would be 2 meter, 29 times. If I just check, see here, I have created multiple surfaces so that my solid is divided. I'll just click OK. See here, we have created multiple surfaces intersecting our tunnel solid. What I'll do is now I'll divide the solid. So we have the option called divide solid. The target would be our tunnel volume. The target would be our tunnel solid, basically. Then the target surfaces we will select using the intersection command. Here you can see all are now selected. 31 surfaces are selected. And just let me reselect the surfaces. We have defined 30 surfaces. So all are now selected. And then I'll just click OK. See here, you can see the tunnel is now divided in 2 meter interval. Okay. Then now let me move this by 10 meter. Okay, so what I'll do is I'll use a same method, translate, then I would select this and select the direction, then I'll be moving it by -10 meter, then I'll name it as, okay, let it be in. Now let me give it a new method, that is grout. Okay, see, all this creating of different geometries would help you, in creating. See here, we have created geometry, initial geometries for the curves, for the soil domain, then for the surfaces. Surfaces, if you see, there are two surfaces were created, one for the tunnel and one for the jet grouting. So what I'll do is I'll just move the jet grouting to the grout geometry set. If you see here, now we have jet grout here separately. What I'll do is I'll again extrude to a distance. Let's see how much we need to extend. Let us measure it from this end, from this point to let's say till here. So we need to move approximately by 36 meter. Okay, so what I'll do is I'll use the translate, then sorry, we need to extrude it because we want it as a solid volume. Select the target object is selected, then the direction, and then let us move it by a distance of 36 meter. Let's see, if you just click the preview, you would see how it would come out. Then geometry is grout set, then I'll just click OK. Here we have created the geometry for jet grout, that is grouting, then the tunnels. Now the next part is to create the soil volume. Okay, now let me select a single soil volume, or three. We can also have a 3-layer soil volume. And before that, if creating the ground, since I said we will be replacing a part of the soil around for the raft by a cushion, so let me have a cushion volume, soil volume that is created. And let me select, we will follow the same method. We'll choose the extrude, select the target object, we will select, basic. We will select the object, select the direction. Direction would be z direction, length would be -1 direction. Then I would be making it as a soil domain, soil domain. So if you see here, if I just click OK, here we have selected the raft or the cushioning raft. Okay, so here if you see the geometry, here we have this solid that is come under soil. Now we will create the soil domain using the geometry or the rectangle defined for the geometry. Then we will use extrude basically. Then we'll select the basic and then the direction, and then we would select the layer. First layer, if you remember, is of a 2 meter. Okay, so I'll give you 2 meter. Then let it be in soil domain, geometry set. If you see, I'll just click apply. Okay, here we have selected 2 meter. Then what I do is I'll select the bottom surface, and then the direction I would extend it further to a 6 meter layer soil, and I'll just click apply. Then I'll choose the bottom surface and I'll choose -22 meter base. uh, yeah, I'll just select the bottom surface, select the direction, and then I'll choose -22. And you see our now our the tunnel and the grout are all covered under soil number 3 or the soil layer 3. I'll just click apply, and then the final would be a last layer soil. Select the direction, and then let me select it for how much we have come so far: 2 meter, 6 meter, 22 meter. So we will have the last layer of 45 meter. Okay, so sorry, we just wanted to have 15 meter. Just select, so -15, so that total we will have a, let me select the direction. Okay, so if you measure, as we have discussed, the length of the soil domain would be around 45 meter. Okay, if you see, we have tunnel from this end extending till here. So now all the most of the geometry is now created. The only thing that is remaining is we need to create or imprint sorry, imprint the raft onto the soil or the cushion soil. So what I'll do is I'll explain you how you can do that. We'll hide all these, and we will just have a first, in the place of raft, you need to convert them into the nodes basically, or the points, and those points can be added to the soil volume. Okay, just give me a minute. Yeah, so what we'll do, we'll go to the points, then under create we'll now convert all these nodes into points. Okay, I'll just go to the select, then I'll just select all the points that are on the raft. So total 110 nodes are created. Now I'll give another name set as a point. Okay, I'll just click OK. See, here we have points now. Okay, now whenever we mesh, we can include them as well. Okay, so then let me switch on all the solids for the soil. Let's say all the solids for the soil and the tunnel solids. Here we have the tunnel solids basically, and we have the solid for the jet grout. So what we will do is, first we need to connect each one of them. Okay, because once you connect all the solids, I'll show you, let me show you. If you see, there are no shared surfaces. If you see, the grout is acting as a separate volume. There is no connection between the grout volume and the tunnels. Okay, and similarly you can see here there is no connection between the cushion soil volume and the top layer. So in order to establish the connection between them, what we need to do is we need to we need to use a command called auto connect, where we will perform a Boolean operation. And now if you check, see, you have the connection in of the cushion, and here you can see there is a shared surface bit for the grout as well. Okay, so this would help you in eliminating any node to node connectivity or node to node connection errors in the future in when you are meshing. Okay, now before we mesh, what we need to do is, the meshing is always happens from the innermost part to the outermost part. So in that sense, we have to do meshing of the tunnels first. Just give me a second. Okay, so what I'll do is I'll hide all them, all of the, or I'll just hide all the solids except the tunnel solid. Okay, so grout I'll hide, then only the tunnel solids. Okay, now how do you mesh? We have different meshing methods for 1D, 2D, and 3D. Before you mesh, you need to define the properties or the materials. I have already defined them, so just to for our convenience, I'll just import them. Okay, uh, I'll just import whatever is required now. I'll just click OK. So we have the materials for the pile, sand and cushion. And if you check, the materials are also now imported. We will see the properties. For example, topsoil, we have modeled as a simple Moore column model where you need to enter Young's modulus and Poisson's ratio and unit weight. Similarly, the porous properties and the nonlinear properties. And the second layer is a dense sand. We have the properties which are a little higher than the topsoil, Young's modulus and the nonlinear properties. And the third layer where our actual tunnel and the grouting is to be carried out is a chalk. Then we have the properties for the chalk as well, general properties, porous and nonlinear. And similarly, we have a bedrock. That is the third layer for us. Final layer here, even though it is a weathered rock, we have the properties of them, nonlinear, porous, and general properties. And we have defined the grout as a elastic, considering its Young's modulus, unit ratio, unit weight, and the Poisson's ratio. We have defined as an elastic material, and we have defined the shield also as an elastic material. So we will see, we'll use them and uh, just for the meshing. This is the tunnel. Initially, all the tunnel volume elements would be have property of the chalk layer. Okay, so what I'll do is I'll just use 3D. I'll select all the tunnels, then I'll use a hybrid mesh. I would give mesh size of 1 meter. Then I would select, since it's a chalk, so I'll call it as tunnel. Then I'll just say apply. It is going to take us some time. Yeah, see, I have created the now all the tunnels. Now the next step is to create the meshing of the grouting. Okay, so if you check here, the tunnels are now meshed. Okay, so now the next step is to create the uh, meshing of the grout solid. So I have selected the grout solid now. Same, I'll go ahead with the size 1 meter, and then I'll use the hybrid measure. Then I'll select this even as a chalk only, because initially all would be of the same soil layer. So I'll just name it as a grout. Later we will use the property called change property and would change it to the respective. For example, we have we will excavate the tunnel, then we'll put the liner, and we will change the chalk of this grout element to the grout property that we have defined. So I'll explain you that in the later stage. I'll just say apply. See, here we have created a grout as well. Okay, now the remaining things are since the once you excavate, you need to give a support system, that is the liners. What you will have to do is, for that what I'll do is I'll hide all the mesh sets, and I'll again choose the tunnel solids. Okay, so what we will do is we will extract the lining elements, so from the solids. For that, let's select the top view. We have the options for extract, then we'll use extract, then we will choose face, and then we choose shield in the initial stage, and later we will change it to final lining aspect. Okay, then let's choose the register based on ownership, and then just let me choose, you know yeah, just let me select, yeah, the option called front selection. I'll just choose 60 objects. This is the top. Let me choose the bottom. So I have selected 120 surfaces in all, and I'll just name them as shield. I'll just click apply. Okay, now if you see, I'll just hide the geometry tunnel solids. If I just hide, you have the tunnels and the tunnels, then shield, and then there is a grout. So all are now meshed. Now the next part is to mesh the uh, ground surface. Okay, now I'll choose the first, then I'll also need to activate the raft and the points as well. So since I need to include the points, or I need to I have imprinted them and I need to include them. I have created the points. I need to imprint them onto the methods. Okay, so that your raft is considered in the analysis. Okay, what we can do is, we'll choose again 3D. In that we will choose, then again we'll have size as 1 meter, then hybrid mesh. Since this is a topsoil but it's a cushion, okay, what I'll name it as a cushion, then topsoil, because the properties of this layer would be replaced by a cushion properties that are mostly of not of the topsoil, but it is a aggregate based properties. Okay. Mm. So topsoil, and what I do is I'll have imprint the points as well. I'll select all the points. I've selected all the points. Then I'll just click on apply, preview, then apply. Now your raft is imprinted onto the soil volume or the cushion volume. Now the next step is to again mesh the surrounding soil. So we will use 3D. Then we'll just use mesh. We'll use hybrid mesher. Then, but this is a topsoil, so I'll just name it as a topsoil. And I'll just check how. I'll just click on apply. So this would be the topsoil. Then the remaining soil layer 2. So similarly, I'll increase this to 2 meter, or let me keep it. Okay, let me go ahead with 2 meter. Then this one would be sand. Then I'll just click on apply. Yeah, then I'll have this third layer, that is a chalk. So I'll name it as chalk. Then let me keep the sizes the same. So I'll just click on apply. Okay, then the last layer, okay, that is weathered rock or a bedrock. Okay, now let us save this somewhere. So I'll just save it as C tunnel with impact assessment. Okay, just let me save here. So now this is bedrock. So we have selected, let me name it as bedrock. Then let me keep the sizes same. Okay, then let me select, then apply. Now all the elements are now meshed properly. Okay, now what you can do is you can hide all the message and even the points. Now you need to define the you know shaft friction resistance and end bearing resistance for the piles. For that we have option for the pile. You just select all the piles and then name it as pile shaft. Okay, just click OK. Here you see the pile frictional resistance is now added. And now time to add pile tip resistance. What I do is I'll just select, then use the intersection option and use the pile tip. Then I would select all the nodes, bottom nodes of all the piles here. You see 73 objects are now selected. I'll just say OK. So now everything is now meshed. Okay, but the issue is, if you uncheck and just check all the tunnels, basically see the naming is not in any of the order. It is very random. 29 is here, then 23 is here, 17 is somewhere there. What we need to do is, because we need to understand which one is excavated in a sequential order, so we need to rename them. So what I'll do is I'll use the option called rename. It's very automatic and very simple. I'll just select use direction Y, then I'll give the method as tunnel. Okay, I'll just say okay. So now you see all are numbered very in a proper manner. Tunnel 001, then we have after 2 there is a tunnel 004, and similarly next is 5. So now I'll know, okay, now all are now in sequential order. Okay, similarly if you see the shield also, even though we have created shield, but their numbering is not proper. So again we will use the rename option. Just select everything, then use Y, then ascending order, then I'll just name it as shield. Okay, I'll just use apply. See, now again these are also numbered properly. Okay, shaft 2 and these things. Okay, so this would be helpful. This will be very helpful when you define the construction stages. Okay, see, this is how we started with the geometry, and now we have prepared pretty much all the we have meshed entire geometry. Okay, now we as I was saying, we need to use the change property option so that we can make the topsoil to the cushion, and similarly we can change the grouting parameters as well. So what I'll do is I'll just select the cushion, topsoil cushion. I'll use the change property. I'll select everything, then use, this is the cushion, so its properties will be changed to cushion. Okay, I'll just say okay. If you see here, the cushion properties would be, I'll just check, modify here, the gravel. So I'll show you gravel cushion. See here, these properties are quite different from the topsoil layer. Okay, so now you can see, now there are red dots here, so which indicates the boundary conditions are now changed, so that you can visualize here. If you see, now the boundary conditions of this is changed. Similarly, I need to do it for grouting also as well. So I'll just select the grout. Okay, then use change property option, then select the grout, choose grout mix. Okay, I'll name it as grout. Okay, I'll just say okay. So now the grout properties are also changed. And one next step is, this shield, all these are now shield. Okay, as a given as a shield, but finally all these are changed to final lining element. So what you would do is you use change property option. Oh, just yeah, I'll use change property option. Then I'll choose particular shield, for example, shield 1. Then I would change the property to final liner. Okay, then I'll name it as S1. Okay, S1, apply. Similarly, I'll change each and every property. See here, you can see the property of the shield is changed. And now I'll choose the next S14. I'll name it as S14 as it is. We have already renamed. See here, you can see you need to change. So this is a repetitive step, which you need to follow, because that is how it is, because you need to activate them each stage wise. So I'll just click on apply. So this is the last step in the modeling, where you would rename all the entire shields, 30 shields, and then you would define the construction stages. So what I have already prepared such a model for you. So now we will directly, I'll just to save the time, I'll show you the simulation, stage simulation here. If you see the construction stage here, this is a stage wizard where you can just drag and drop different mesh sets, and your entire construction sequence is now created. If you just check the construction sequence, I'll just show here. See, initially you have only the ground profile without any change in the properties here. And now the next you would have the piles and the raft and the cushion. And then you have the tower in the stage 3 along with the dead loads, okay, which are imported from MIDAS Zen. Okay, then you see the first tunnel is now excavated, the tunnel is excavated, and now the shield is provided. In the second stage, we are changing the conditions of the grout first. I'll just show you, I'll just hide the soil layer so that it would be visibly more appealing to you than the sand and the chalk. Yeah, okay. I would just hide I just hided them so that you'd be able to see here. And in the previous step there was no jet grout. Now we changed it to the jet grout. The boundary condition is now changed. Now if you want to see that, you can see here the jet grout, you can see the boundary condition is now changed. Now the excavation 3 third stage, and here you can see the boundary condition of the first lining is changed to S1, that is final liner. So similarly, as we progress, you have the stages from 1 to the last stage. Okay, once the stage construction is defined, I can also show you a simulation. If you just scroll here, with all the mesh sets checked, and let me select. So if I just play, you will have different construction activities going on. See, you can see here. So this is how you can visualize your construction sequences, so that whenever you have any doubt, so you can go and change in that particular stage. And next step is to analyze. You need to create the construction stage and give the analysis control options. For example, initialize the stress, apply keynote condition, clear strain, and you just need to solve. Okay, now we have already analyzed this model for you. I'll show you. Since in the ground, in the initial stage, we don't want any displacement because it's a ground in situ ground condition. But from once we have the foundation, see, we have a small amount of the displacement here of around 4 mm. Then subsequently, as you undergo tunneling, excavation, then putting shields and liners, the finally you would have a displacement of around a range of 40 mm maximum. You can see here how your tunnel got twisted or tilted basically because of the excavation. Okay, so you can see. So this is how you can understand the behavior of the tower. And if you want to see the beam element forces, you can see that bending moment for the piles as well. I'll just show only. So you can see the bending moment, variation of the bending moment, and then these are the axial forces or the shear forces. So this is how you can check the different results. And suppose you want to just let me show you. you want to cut a section and view your results at a particular this thing, let's say how add, then close, then you can see here how the displacement would happen. So or else you can cut another section at under the building, just add, close, then close. You can see the variation of how the displacement profile would occur. Just you just need to select the displacement. Okay, so this is how the displacement would happen at different stages. I can just scroll and check the stress counters, whether I have defined the boundaries correctly, or I need to expand the boundaries a bit, so that your boundary effects are all now are negligible. So this is what was planned for the today's webinar. I think we are pretty much close to the uh, ending of the session. I would like to have any questions if anybody has given. So I'd request the attendees to type their questions so that I'll be able to answer them. Hello, Angocho, any questions are there?
Pravin, I made you an organizer so you can check through the questions tab.
Thank you, Angocho. I think these are now answered. Okay, just let me stop the presentation. Now I'll have the question. Is, will this distance represent the observed effect after the model? Yes, I think we have discussed that. The tunnel cross section is solid. Still need to turn this into a hollow. Cross section, I didn't get your question. The tunnel cross section is solid. That is why we have given the lining elements. Okay, once you excavate, let me show you. Okay, see, I'll just hide. I'll just hide the soil layers. Okay, see the tunnel. Once you excavate this particular soil, if you don't provide any support, then there would be stress relaxation from all the sides. So in order to restrict that, we need to give solid. Suppose I excavated this lane, see immediately the liner or the shield element is activated. So this is how you would do it. Okay, so this is the last question. I hope I have addressed your answer. So if there are no other questions, I think Yangochoy, we can end the session.
Okay. Yeah, I think there's no other session and no other questions. So yeah, let me end up the webinar. Thank you all of you to attend this webinar. And for the attendees, we will send you the PDF version of the presentation file through email, and also we'll include the link for the YouTube video for this webinar. So please keep updated for your mailbox. Thank you. And thank you, Pravin, for the presentation.
Sure. I also thank all the attendees for attending the webinar.
Okay. Thank you. Bye. Have a
Thank
good
you.
time.
Have a good day.